Okay, you guys ready?
No.
No? Okay, anyway, we are going over this, so hopefully this review is going to be helpful.
What page, mister?
Review.
Review doesn't have one.
I have one. Don't say I don't have one.
Okay, so let's take a look at this. Prove that all circles are similar.
They are.
They are. Why?
Because they're all circles.
They're all circles. They're all the
Same.
same what? Same shape. They're all the same shape, aren't they? Okay, they're all the same shape. If they're not the same shape, then that means
They're not.
they're not a circle.
They're not circles.
Okay, so they're all going to be similar. All right, so circle Q has a center at -4, 5. So -4. 1, 2, 3, 4. 2, 3, 4, 5. And has a radius of 2. So radius of 2. I'm going to try my best to actually. Oh, I'm sorry. You're right. Radius 6. Forgive me.
First time I'm actually
1,
right.
2, 3, 4, 5. Oh, wait. 1, 2, 3, 4, 5, 6. So. Where's my notebook? There it is. Okay, so now I'm going to try to draw this. So yes, sorry, it goes off the circle, but you know what? It's fine. Deal with it. All right, so we have our circle there. Circle T has a center at 1, -4. 1, -4. 1, 2, 3, 4. So this was circle Q. This is circle T. And radius of 2. This is going to be a pain to draw.
That's cool.
There we go. So, QT.
You got a little
Picture?
over there?
All right. So, right here. Describe a transformation from circle Q to circle T to prove that the two circles are similar. So, first, are they the same shape?
No. Yes.
Shape.
Yes.
Yes, they're both circles, right? Are the same size?
No, sir.
No. Okay. So is there a dilation happening?
Yes, sir.
Yes, a dilation
I don't even know
of what? How do I get that number?
Multiply by 3.
Nope, try again.
No, you
Divide
put
the
2 over 6,
Very good. 2 over 6.
and then you simplify it.
Very good. That's what I'm looking for. So it's going to be 2 over 6 because it's the second radius over the first radius, right?
Yes, sir.
This is what we did the other day. So it's a dilation of 1 over 3. So 1/3, that means it's getting smaller, right?
Yes, sir.
Okay. So now let's do everyone's favorite.
That's an understatement.
No, it's Madagascar. Everyone's favorite because they like to.
Move it.
Yes, move it. All right. So x comma y is translating x. Now, is it moving to the right or left?
Right.
To the right. So what am I going to put here?
Do the positive line.
Positive. So a plus. How much did it move over?
5.
5? You guys agree?
Yes, sir.
Y. Is it moving up or down?
Down.
So what goes there?
Negative.
Negative. How much did it go down?
7.
9.
No, 9.
1, 2, 3, 4, 5, 6, 7, 8, 9. Yes? So this is right here, and because of that, so all circles are same shape. Right, exclamation point, that one. All circles are always similar because they're always the same shape. They're just different sizes. Okay? Are all circles similar?
Yes.
Yes, sir.
All circles are same
Shape.
There we go.
No one says hi, Q, I stand for equal P rights.
Okay, next one. Given the following diagram of the plate, what is the length of AB? Okay, so AB, that's that right there. So we just did this the other day in the notes. Let's see, they're crossing in the middle, right? They're crossing in the middle. So this is, when I was actually teaching this, I told you guys, you had your two colors, and what do?
You put it on A, D.
Curl,
Okay.
color both sides.
Okay, yeah, let's color like that,
Yeah.
right?
Yep.
So, you guys remember from the notes right here? So, to do this math, I would write what?
X.
6,
X, let's do X times
14,
equals,
16 times 21.
14.
yep, just like that, right?
Yeah.
So, we're multiplying across here. This is the same way we did it in the notes. Okay, so this side I know I get 14x. Equals 16 times 21?
336.
336.
It's 24.
Divide both sides by 14.
X.
24, you guys agree?
Yeah.
Okay.
This is fine.
It's the length of AB, so it's 30.
Oh, thank you, thank you, thank you. Thank you. You have earned yourself a prize
Okay.
for proving me wrong. I have forgot about
Proved you
that.
wrong many times. I've never got a prize.
I offered it to you, but you know
When
what?
should you offer it to me?
All you ever want to show me is your Fortnite wins. All right, AB. So AB, so if we plug that in, so it's going to be 24s right there, and from A all the way to B is going to be how much?
38.
24.
What is it?
38. Never mind.
There you go. All right, given the following diagram, what is the value of x? Now, what type of triangle do I have here?
Right.
You are right.
It's a right triangle.
It is a right triangle.
That's cool.
And in a right triangle, how do I find the missing side of a right triangle? Pythagorean Theorem.
I said to go left.
Yeah, you know what? I think I will left that joke over there. Alright, so let's go ahead, Pythagorean Theorem. So which one's going to be my C value? That's going to be this whole thing over here, right? So I would write 6 squared plus 8 squared equals C squared. There's my ABC. 36 plus 64. 100.
100.
C is what is the square root of 100?
100.
10, thank you.
We have that.
10 is. It's 10 is.
This whole thing right here is 10. Now, it's only asking for this little piece out here, right? What's the piece from right here to here?
6.
Why is it 6? Say it again. It's the radius, isn't it? If my radius is 6, isn't this radius also 6?
So X equals 4.
Man, did you hear that? That sounded like mine blowing up right there.
No. If you want to hear mine blow up, you should know that.
You're going to say something about your Fortnite win,
no,
right?
every odd number has an E in it.
Okay, so
Really?
right here. Now, if the whole thing comes out to be 10,
Hey, everybody's actually gonna test that.
I know, right? So yeah, thanks for totally messing up my class.
Because I was doing it right now in my head too. I was like, everybody's gonna do that.
All right, so let's see. Maddie, can you tell me what this one right here is? What's my x then?
16?
Say 4.
I just said 4.
I know, I heard you say 4, but someone said 16 for some reason. Okay,
That's the one that's
4.
Bro.
Because the whole thing has to add up to 10, my radius is 6, so the missing piece is 4. So x equals 4.
Watch, bro. See?
Alright, hey, you guys know I'm still recording this, so come on now.
Oh, I mean,
Bro,
Huh?
if you put comments on it, it'll be like that.
You didn't get
kid
it?
That gave us that
You didn't
that
get one of
little
these?
thing is
No, I
like
didn't
the
get
most
the-
genius thing of planning.
Oh, what?
The last part.
So, which part right here?
Oh, no, I just did it.
Oh, you're still writing it down?
Yeah.
Okay.
Miss Lewandowski told me that was the dumbest
Hey,
thing she's ever
hey.
done.
Seriously, I really don't want to hear these conversations when I go back and watch the video.
Okay.
Because, you know, even that teacher could hear that you're talking smack about her.
Oh yeah.
Okay.
Thank you.
Okay, so,
He got caught, bro.
alright, so let's take a look at this problem right here. Now, given AP and BP are tangent to the circle. Now, tangent, when the tangents touch the edge of the circle, what angle does it form with the radius? It's really important.
Say it again?
The tangent, right here,
Yeah.
the radius and the tangent form what type of angle? 90 degrees, so I'm going to put a little right here and right here. So every time the tangent's touching the radius, like this, it forms a 90-degree angle. So from that,
Sure.
okay, so back to the video. All right, so right here, what type of triangle do I have on the top here?
right triangle.
Right triangle, very good, right? So I will emphasize this piece right here. There's a right triangle. So if that's a right triangle, how can I find the length of OP? Very good, Pythagorean Theorem, so let's do that. So OP is going to be the C value in my Pythagorean Theorem, right? So I'm going to have 5 squared plus 8 squared equals C squared. 25 plus 64 equals C squared. What's that, 89?
Yeah.
So C is equal to the square root of 89. So C is a boot.
9.4.
9.4? Do I have units? Centimeters, very good. Always try to make sure that you're putting whatever units we have there. Explain the properties of circle and tangents you use to find the length. So what did I start this off with?
5.
Nope, not this. When I get this information right here.
Oh, you identified what column?
Okay, so what did I say? What did I say? What's the first thing I said?
You said
The tangent does what?
it makes 90 degrees.
90 degree. Okay, so the tangent. So the tangent makes a 90-degree angle with the radius. So it's almost word for word of what was in the notes. Yes.
Can I get the water?
Yeah.
Sounds about right.
All right. Are we ready to move on to the next one for 5? You guys finished writing that down?
Yes.
Okay. So let's take a look at number 5 now. Okay, given measure of what's that actually terminology? What is that? Arc, RT. Is that a minor or a major arc?
Minor.
Minor arc. So a minor arc is how much?
136.
A minor is less than
90.
Oh, kill me.
180.
180. Less than 180, right? And minor is less than 180. So let's see. Find the following measure. So if this is my RT right here, this is my arc, the angle that goes with that would be right here. This angle right here. So this angle right here, this is called a central angle. What do we know about the relationship in between the central angle and the arc?
Yeah, it's half of it.
The central angle is half?
No, the central angle is the radius.
It is what it is, right? They're the same. The central angle is the same as my arc. Okay, you guys are talking about the inscribed. The inscribed is way over here. Okay, so now this one right here, so I know that angle RST from here to here is going to be 136 degrees. So RST, because that the central angle is the same as the arc. Now the next thing I'm looking at is this one over here. This is my inscribed angle. An inscribed angle, right here. Here's the arc. It touches the other side of the circle. This one is going to be half of my arc.
68.
So this one is half of my arc. So I take my arc, which is 136, and I would divide that by 2. So angle A is going to be, you said 68?
68.
Because it's my 136 divided by 2. Are we okay still?
Yes, sir.
Alright, the next one is going to be angle STR. Angle STR. So it's going to be this over here. So it's just this little piece. ST to R is right here. Now, if this is the radius, SR is a radius, isn't ST also a radius? Okay, so let's see. If I know it's a radius, I know that this radius is congruent to this radius. So those radii are the same. So in the triangle, what type of triangle do I have there? Starts with an I. Isosceles, yes. So it's going to be isosceles triangle. So in an isosceles triangle, what do we know about these two angles right here? They're congruent. They're the base angles. So the base angles are congruent. So using this right here, I know that all three angles need to add up to how much? 180. So mathematically, I don't know what either of them are, do I?
No.
But I know they're the same. So if I say this is going to be an X, and this is also over here going to be an X, I would say that 136 plus X equals 180, right? Because I don't know that one, I'm saying that's X, but I just know it's the same as that. And 136 is that one known angle in there, and all three together have to add up to 180. So combined like terms, how many X's are here? 2. So I get 136 plus 2X equals 180.
Oh, I know what it is.
What I'm going to do from here?
Minus 136.
Very good. Subtract 136. So 2X is...
22.
What's that going to be? It's
124.
44? 44, right? Divide by 2. X is 22. degrees.
Mister, you know what I did? I can do that, but like, I don't know. I just did 180 minus 136, and then I got 44, and I divided by 2 because both those angles.
Yeah, that's the same thing.
Okay.
Yeah, that's fine. So we said angle STR is 22 degrees. Jess.
Yup.
Okay.
Wait.
Alright, let's take a look at this one over here. What is the value of x? Now, this one, we can go back to the notes on this one. Where are these things crossing at? Is it inside the circle or outside the circle? Inside. They're crossing, and I'm going to actually go and I'm going to pull up the notes so you know exactly which ones we're talking about. Now, there's something I have not mentioned in a while because I'm hoping you guys have been keeping up with it yourself.
Yeah.
Is there something you could use in your handy dandy? Have you been keeping up with your handy dandy? Okay, needs an update. So, our handy dandy that we have for this unit should be updated with a lot of these formulas. A lot of it's already in there, but you just need to put in the formulas that go along with it. Let's see if I could actually...
Mister, we turn our notebooks next week on Friday, right?
Yep, next week on Friday.
Wait, are we doing 18 merit tests next week?
Yes, we are.
On Wednesday?
Okay, so let's take a look. I'm showing you guys, these are the problems that we've already done that are just like this.
Watch, can I use the restroom?
Yeah.
Actually, never mind. I'll just go.
So listen up real quick. Here's the formula. It goes along with this. So it's 1/2 my 2 arcs. So if I'm finding the angle on the inside, which is right here. So I'm finding this one right here. So this angle right here is 1/2. So angle x equals 1/2 86 plus 88.
174.
Okay. So it's 174, is that what you said?
Uh-huh.
And it's half of that.
97.
Oh my god, bro.
So angle x is 87 degrees.
I envy her right now.
Why? Did she pay attention?
No, it's not that.
So you jealous?
I mean, I pay attention too, but I still don't get crap.
Alright, let's take a look at this one. This was part of the same set of notes. What, am I waiting?
I'm gonna pretend like I knew what the hell you just did.
Wait, that was it for that one?
Yeah, that was it.
Is that the formula that's in our notes?
Yes, it's in the notes. I just showed you the notes. Look, here's a blank copy of it right here.
Oh yeah, okay.
Ooh.
And here's the one that we actually did in class. Right here, actually working it out. I have my angle. So it's 1/2 the sum of my 2 arcs.
That's smart.
Okay, so on the same set of notes. Same set of notes. Same set of notes. Now for number 7. Is this line right here a secant or a tangent? It's a secant. It's cutting all the way through, right? So let's take a look. Same set of notes.
It's half minus 28.
Here it is right here. It is 2 secants. So this one right here has a subtraction. So it's my big arc minus my little arc would be equal to the angle out here. So it's going to be angle x is equal to 1/2. What is my big arc in this one?
90.
90 minus my little arc, which is, okay, so that's going to be angle x equals 1/2 of,
70.
It's not even that
X
hard.
equals 35 degrees.
I'm facing no friend. Bro, I used to like
All right. 8.
So yeah, I don't see the
Okay, so given right here, Circle K. Now this is task 4. Given Circle K below, what is the radius of Circle K round to the nearest tenth? Now,
What's that little thing?
okay, this is the piece. This is your 20. Now, this around the outside, what did I refer to it as? Pizza crust. Pizza crust. So the pizza crust formula,
No one likes crust.
2
I do.
pi times
I
radius.
wrench.
2 pi times radius. Okay, and for this one right here, for the sector, it would look like this. C is equal to, it is my theta, whatever my angle is, divided by 2 pi times pi, I'm missing a 2 right here, 2 pi r. Because we're looking at our fraction of this. Our fraction of my thing right there. Okay, when we actually did this in the notes, we were talking about this. We didn't actually do too many problems with just the radians. All you have to do is identify that the fact that this is a radian and a whole circle in radian is 2 pi. A whole circle in degrees is how much? 360. So that's the only difference in this. So if we're looking at this, I'm multiplying and dividing by 2, and I'm multiplying and dividing by pi, right? So this and this will cancel. So C is equal to my r times radius. Circumference is the same as saying the arc length.
Wait, did you say r times radius?
Yeah.
I thought that means theta.
Yeah.
R times theta, right?
You said radius.
Oh, I did. I'm sorry.
I was
It's
like,
my radius
okay.
times theta. You got me there. Okay.
So
So, let's see. What information for this do I have here?
The radius.
The radius,
No.
I don't know the radius, right?
No.
But
That-
this would represent what?
the diameter.
Theta.
Oh.
It's my theta because in my formula I only have an angle and the radius, right? What's the circumference? What's the portion of it I have?
20.
20. So the piece that I have right here is just 20. So it's going to be 20 equals
R
r
times
times
6 pi 5.
over 5. Very good. Am I trying to get r by itself?
Yeah.
Yeah. So what would I do to get rid of this?
You would multiply it by that. Right?
Yeah, by
no,
each side.
divide.
I would divide because this is already multiplication, right?
Yep.
So divide both sides by 6 pi over 5. So in your handy dandy calculator,
Do 20. That one.
yeah, it's 20.
Divided by.
So 20 divided by,
It's 2.9439510.
6 pi over 5. So, and it says round to what? In nearest tenth. So I'd say that's going to be 5.3. So R, 5.3, what are my units? Centimeters. Using your answer from part A, what is circumference of circle K? So, what is the whole circumference now? So now, the whole circumference. So if I use this right here, this is the whole circumference. So I'm asking for the whole thing of the whole circle. C is equal to 2 pi, what's my radius?
5.3.
5.3. Because I use the answer from this one into my radius here. plug that in the calculator. Whole circumference should come out to be centimeters. Using your answer from part A, what is the area of circle K? Okay, area formula. Area is equal to pi r squared. So my area is equal to pi, my radius, my 5.3 again, squared. So these ones should be just very easy as long as you get your first one. 88.2 to the nearest 10.
Yeah, 88.2.
And since it's area, what would my units be? Centimeters squared. Very good. D. Using our work from part C, what is the area of the sector bound by points LKM? So LKM with the central angle of 174 degrees. Round your answer to the nearest tenth. So we're trying to figure out what's the area of the sector. So I'm using all this right here. So for this, it's basically a fraction of my entire area. So this is going to be times. So they gave it to me in degrees, so that's why I'm doing this one in degrees. So you could do all the math over again, or you could just take whatever my area and times it by the fraction. Should be 174 over 360 because the 360 is a whole. 174 is just the piece that I have. Multiply times that, and I should end up with 42.63. 42.6, and that's going to be cm squared. And this is only for my sector. Just that little piece. Just that one slice that we're talking about. So it's only referring to this slice right here. Yep. All right, so we're going to pick up the rest of this on Monday. All right? So, don't forget, like and subscribe.